From space, it's a masterpiece of atmospheric physics, a swirling engine of immense power, both beautiful and breathtaking. But down on Earth, it's one of nature's most formidable forces. For centuries, we have tracked them, studied them, and tried to understand their secrets. But in our lifetime, a new question has emerged, one that has become one of the most significant scientific puzzles of our era. Is the engine changing? In a world that is undeniably getting warmer, are these iconic storms evolving right before our eyes? The answer isn't a simple yes or no. It's a story found deep within the data, full of surprising turns and fascinating science. Hey everyone, and welcome back to the Hurricane Watch team. Today, we're stepping away from the immediate forecast to tackle that huge question. The one that surfaces every time a major storm brews in the tropics. Is climate change making hurricanes worse? It's a topic where the conversation can get very loud and very heated, very fast. My promise to you today is that we're going to tune all of that out. We're not here for the hot takes or political arguments. We are here to be data detectives. Our mission is to calmly and clearly look at the peer-reviewed science, the hard evidence, and understand what it actually tells us about these incredible storm systems. We're going to break this all down into 4 key questions, and some of the answers will likely surprise you. This isn't about fear, it's about clarity. Let's get started. Part 1. The question of frequency. The most and first common thing you'll hear is that we're simply getting more storms. You see the news anchors talking about running out of names, dipping into the Greek alphabet, and it feels like the Atlantic is a non-stop hurricane factory. On the surface it seems obvious, but this is where our detective work begins, and we uncover our first major plot twist. The truth is, it's not that simple. To understand why, we need to travel back in time to the pre-satellite era. Before the 1960s and 70s, our ability to see the hurricanes was remarkably limited. We only knew a storm existed if a ship was unlucky enough to sail through it, or if it made landfall. Now imagine a powerful hurricane spinning for 10 days over the open ocean, hundreds of miles from anyone, before eventually weakening and dying out. Now in today's world, it would be named, tracked minute by minute, and analyzed endlessly. Back then, it would have been completely invisible to us. It would have never made it into our official records. We were, in essence, watching the skies with one eye closed. When we launched weather satellites, it was like turning on the lights in a dark room. Suddenly, we could see everything, everywhere. Of course, the numbers of storms we counted went up because we were no longer missing the ones that stayed out at sea. Furthermore, there are natural, decades-long cycles in the Atlantic, like the Atlantic Multi-Decade Oscillation, or AMO, which can create periods of higher and lower storm activity. When you account for these factors, the global data, for the total number of hurricanes, and especially the major hurricanes, it doesn't show a clear, sustained, dramatic upward trend. It's more cyclical. So, is a warming planet creating higher quantity of storms? The scientific consensus, based on the current data, is that this claim is just not well supported. Yes, the numbers are up, but it's more a story of better detection and natural cycles than a definitive increase in formation. But that's just the first chapter. The more important story isn't about the number of storms, but their character. Part 2. The question of intensity. This is where the picture starts to change. Now let's think about a hurricane in the most simplest of terms. It is a giant heat engine, and like any engine, it needs fuel to run. In hurricanes, high-octane fuel is warm ocean water. The warmer the water, the more energy is available for the storm to tap into. And our planet's oceans have been absorbing an enormous amount of the excess heat from the atmosphere. over 90% of it, in fact. This isn't about the surface temperature, it's about the depth of that warmth, what scientists call the ocean heat content. Imagine trying to boil a small pot of water versus a giant cauldron. The giant cauldron has a much greater reservoir of heat, and the bubbles can become much more vigorous. In the same way, as our oceans store more heat energy, the maximum potential intensity. Think of it as the theoretical speed limit of how strong a storm can get is increasing. We are effectively raising the ceiling for what is possible. While not every storm will hit this new ceiling, the data shows we are seeing a higher percentage of storms that do develop reaching those top tier category levels of category 4 and 5 intensity. So, are the storms we get becoming more powerful? The evidence says yes, indeed, the potential is increasing. We've enriched the fuel source, and as a result, the potential for truly high-end, powerful hurricanes is growing. Part 3. The question of rapid intensification. This leads us to a phenomenon that is a major focus for researchers and forecasters. It's called rapid intensification, or RI. This is defined as a storm's wind speeds are increasing by at least 35 miles per hour in 24 hours. It's the atmospheric equivalent of a car going from just 0 to 60 in just a few seconds. For coastal communities, this is a significant concern because it dramatically shrinks the preparation and evacuation timeline. A storm that was a manageable Category 1 yesterday could be a formidable Category 4 today. The key ingredients for this explosive development are that deep layer of warm ocean water we just talked about, combined with low wind shear in the atmosphere. Now, wind shear is when winds are at different altitudes blowing at different speeds or directions, which can rip a developing storm apart. But when the shear is low, a hurricane can create perfect, uninterrupted vertical chimney, venting heat and moisture from the ocean high into the atmosphere, allowing it to strengthen incredibly fast. Hurricane Otis in 2023, which struck Acapulco, is a dramatic case study. It went from a tropical storm to a catastrophic Category 5 in just over 24 hours. Fueled by a deep pocket of exceptionally warm water, while this is an extreme example, observational studies are showing that these RI events are becoming more frequent. The conditions that allow for them are simply more common than they were decades ago. So, are storms intensifying more rapidly? The data indicates this is a growing and a significant trend. It's one of the most direct and impactful ways a warmer world is changing the behavior of hurricanes. Part 4. The question of water. And this brings us to our final point, which may be the most consequential change of all. For all the focus on wind, history has shown us that water is the most dangerous part of a hurricane. And here, a warming climate is delivering a powerful combination of two factors. First, they are wetter. This is a matter of straightforward physics. Warmer air can hold more water vapor. For every 1 degree Celsius of warming, the atmosphere's capacity to hold moisture increases by 7%. Think of the atmosphere as a giant sponge. We are making the sponge bigger and more absorbent. So when a hurricane moves through and wrings out all of that atmospheric sponge, the potential for extreme, record-breaking landfall is significantly higher. We saw this with the devastating flooding from storms like Harvey and Florence. Secondly, there is emerging evidence that they may be getting slower. The large-scale weather patterns that steer hurricanes, like the jet stream, are a bit like rivers in the sky. Some research suggests that as the planet warms, these steering currents may be weakening. A weaker current means storms are more likely to move sluggishly, meander, or even stall over an area. When you combine a slower storm with one that is carrying more moisture, you have a recipe for a catastrophic flooding event. So, are hurricanes becoming wetter and slower? The link to increased moisture is extremely well established. Now, the link to slower speed is an active area of research, but a deeply concerning trend. Together, they represent a fundamental shift in the primary threat many communities face. So, let's put on our detective notes together. Are there more storms? The evidence isn't really supported, we're just better at detecting them. Are they becoming stronger? Yes, the potential for high-end intensity has increased. Are they strengthening faster? Yes, and this is a major challenge for forecasting. Are they producing more rain? Absolutely, and this may be one of the most dangerous evolutions of all. The story of hurricanes in a changing climate isn't about quantity, it's about quality and character. The storms we face today are on average carrying more water, having a higher potential to be stronger, and to strengthen faster than the storms our parents and grandparents knew. This knowledge isn't meant to cause anxiety, it's meant to build respect. It's a call to action. To not just look at the category of a storm, but to pay close attention to the specific threats of rainfall and storm surge. It empowers us to make smarter decisions. If you found this calm, data-driven deep dive helpful, please consider subscribing and turning on notifications. Our goal is to always be your source for clear, understandable information. And if you know someone who would benefit from this clarity, please share this video. In a world full of noise, a little bit of signal can go a long way. Thanks for watching. Stay safe, stay informed. This is the Hurricane Watch team, your #1 source of cyclone information. Peace out.